Assalamu alaikum everyone. Welcome to the first video of Chemistry with Sarab Sambe. We're going to start off with our very basic chapter that is states of matter. Before we talk about the states of matter, we need to see what matter is. Matter is anything that occupies space and has weight. So for example, the chair you're sitting on, or the pillow you're resting on, or the pen you're writing from, or the book you're reading from, even the air you breathe in, despite you not seeing it, it still matters because it occupies space and has weight, right? So let's look at the three states of matter: solids, liquids, and gases. There has been other states of matter being identified and discovered, but for our syllabus purposes, it's just the three states of matter: solids, liquids, and gases. So let's take the example of solids. Solids can be ice, solids can be all metals except mercury. All metals in their pure form except mercury are solids. Liquids. The water you drink, water in its liquid form, water, ethanol, any form of oil, they're all liquids. Gases, water vapor or steam, you can say. Or you can say carbon dioxide, the gas you breathe out, CO2, or oxygen, O2, the gas you breathe in, right? Now, the first question arises that how are these three states of matter different from each other? So let's see. These three states of matter are different from each other based on these five properties. The first property is shape. So solids have a fixed shape, as we all know. Solids do not change their shape until and unless they're melted. Liquids do not have a fixed shape. And they take the shape of the container. They take the shape of the container in which you add them. Take the shape of the container. Or I can just write they take the shape of the container. Take the shape of the container. And so would gases. Gases will also take the shape of the container because they do not have fixed shape either. In terms of volume, solids have a fixed volume. Liquids also have a fixed volume. But gases do not have a fixed volume. Gases will also take the volume of the container, shape and volume both. Compressibility. Compressibility is the ease to which I can compress, I can put force on a particular substance. So solids are not compressible. Even if you put force, nothing will happen. If you try to put force and to try to reduce its volume, nothing will happen. Liquids are very difficult to compress. And gases are not compressible at all. Oh, sorry, gases are very easily compressible. My bad. When we talk about ease of flow, solids obviously do not flow. Liquids will flow and gases will also flow. And when you talk about density, density you must have studied in physics. The density is equals to mass per unit volume. So solids are highly dense. Liquids are less dense than solids. And we talk about gases, gases are very less dense, a very low density. Now, after studying these five properties, we have to look at how the solids, liquids, and gases have particle separation, arrangement, and motion. How are the particles separated in a solid, liquid, and gas? What are the arrangement of particles in a solid, liquid, gas? And what are the motion of these particles in a solid, liquid, and gas? So when we talk about particle separation, in solids, the particles are very close together. The particles are very close together. In liquids, the particles are not as close as they are in solids. And in gases, the particles are very far apart. Now let's look at the arrangement of particles. So particles in a solid, since we said that they're closely packed, the particles are very close together, how are they arranged then? They're arranged in a regular manner, in a regular lattice structure. And when we talk about lattice, lattice is a regular array or arrangement of atoms, like in a proper pattern, in a regular lattice structure. The arrangement is regular. Liquids, irregular arrangement. The particles are not regularly arranged, they're irregularly arranged. And when we talk about gases, gases are super irregular and their arrangement is absolutely random. Irregular arrangement. And when we talk about motion, the particles in a solid will only vibrate to and fro about their fixed positions. They're only going to vibrate. When we talk about gases, gases have an absolutely random motion, like the Brownian motion you must have studied in physics. Random motion. And we talk about the motion of liquid molecules, they can move about and slide over one another. When we also talk about the intermolecular forces or the electrostatic forces of attraction between various solid molecules or particles, liquid molecules or particles, gases molecules or particles. So the intermolecular forces or the forces of attraction are really strong. Particles are very close together due to strong, we can say due to strong electrostatic attractions. The very strong electrostatic attractions. And because of that, these particles are arranged in a regular lattice and they can only vibrate to and fro about their fixed positions. When we talk about liquids, particles are not as close as they are in solids because of the weaker electrostatic attractions as compared to solids. And gases have the weakest electrostatic attractions. So if the question comes in about electrostatic attractions, we know that solids have the strongest electrostatic attractions between particles and gases have the weakest electrostatic attractions in the particles. The next question after the difference in properties arises that can we convert a solid into a liquid into a gas gas back to a liquid, and a liquid back to a solid? Yes, we can, and that part of the syllabus is changes of state, which we are going to cover in our next video. So stay tuned. Till then, let's wait for the next video.